First, I want to apologize for my English. I have two excuses. The first is that I am French, but it's not a good excuse because you speak very well. And the second is because I did my postdoctoral in Caracas, and I spoke Spanish. My mother is from Spain, thus I did not have the opportunity to improve my English when I was in postdoctoral. Thus, we can speak Spanish if you want, but okay.
No, you can't.
Okay, thus I will tell you the story of this incredible outbreak of Uro-genital schistosomiasis in France, and I had also some new results we have obtained in my group. Okay, the story started in 2014 when a physician from Germany, Professor Joachim Richter, called to my group, called Hélène Monet, and he called us because we are a WHO collaborating center in Perpignan, in the south of France, you see, near Spain. I am an hybrid between French father and Spanish mother. Thus, Joachim said to Hélène, "Hi Hélène, I have a strange case of schistosomiasis. A young boy, 12 years old, with a macroscopic hematuria. There is no any doubt. You see in the picture the toilet of the young boy. And only 2 days after, we have another call from France, from Professor Antoine Berry, Toulouse, near Perpignan. And Antoine said to André Théron, another colleague of my group, "Hi André, I have a strange case of schistosomiasis. A young girl, 4 years old, with a macroscopic hematuria since 1 month, and there are some eggs in the bladder after biopsy, and also in the urine." What is it so strange? Every year in France we have between 4,000 and 5,000 cases of bilharziasis. But all these cases are important. They are all traveler infection. We received just a few days after some eggs of the parasite incriminated on the patients, and there is no any doubt this is an egg of Schistosoma hematobium. This is the repartition of Schistosoma hematobium. This repartition is very well known, Africa and Arabic Peninsula. And the analysis of the patient relates some travels in Tunisia, Mauritius Island, Brazil, etc. There is no link between the endemic countries of Schisto and the travels of the tourists. Rapidly, we focused our analysis, our investigations on the Corsica Island. I suppose you know Corsica Island is a well-known island for touristic attractiveness in the Mediterranean. The people in Corsica jump from 300,000 people in winter to 3 million in summer. And the two families spend their holiday here, near Porto Vecchio, in a little village called Saint Lucie Porto Vecchio. And this village is at the embouchure? Yeah. Thank you. Of a well-known river called the Cavo River. And this river is the most frequented river in Corsica with 3,000 to 5,000 people every day. You can see this really a beautiful river with the crystalline water. And just to show you the people on the Cavo River, this is a newspaper in Corse Matin. Remember the date of the paper, 2016? Okay. You can see the San Martino Valley stronger than bilharziasis. Okay, it's funny. There is 72 people in this picture. Okay, thus the first question was, yes, I suppose you know the life cycle of schisto. If you have human infection, you need to have a mollusk intermediate host to do the life cycle of the parasite. That's the first question of the public health in France was, is the mollusk present in Corsica? To be honest, I did not know. I worked on schisto since 20 years. I did not know that Bulinus snails was present in Corsica. This is the last description of the snail in Corsica. Each black point corresponds to the presence of the Bulinus snail. The health authority in France say to my lab, you have to check if the snail is present in the Cavo River. It is obvious for us because if you have schistosomiasis infection, you need to have the snail, but because the Corsica Iceland is a beautiful place, we said, okay, we go. And 10 minutes after looking in the river, of course, we found thousands and thousands of the classical intermediate host for Schistosomia hematobium, Bulinus trunculatus. Okay. Then we look for infected mollusks. Thus, you can see the story continue until next summer. We have tested thousands and thousands snails. We never found any infected. The two first years we look for the presence of the parasite by sacral emission, and then by more sensitive PCR test. And around, you see around 20,000 snails never found positive snail in the river. We showed that the local mollusk can be the intermediate host by experimental infection. We have exposed local snail by the parasite coming from infected patients, and we observe positive snail thus, and now we maintain the life cycle of the Schistosoma corsicae in Perpignan. Okay, next we were interested on the human part of the life cycle, and mainly where and when the contamination occurred. For this, this is in 2014, after the first outbreak. You can see we had some pictures from tourists infected. This is a true picture. You cannot see the faces of the patient. All these patients were infected. And we have also done some meeting along the river with the locals infected, asking where did you took your bath in the river. The objective was to identify precisely where the contamination occurred, because the river is 12 kilometers long, and we wanted to know exactly where the patients were infected. Thus, we did this kind of matrix. You can see that the local number, this one, take bath only on the site 9, and you can see that two sites are independent, the site number 8 and the site number 9. There is around 900 meters between the two sites. It's too far, I think, for schistosome to cross between these two sites. Certainly two independent sites of infection. Thus we have two sites. Just you can see that this grass, okay, I come back, this grass. Okay. There's convergence between the site and the pictures. Thus, you can see the river here, Saint-Lucie Porto-Vecchio is here, and the two sides are these two sides, and you will see later a big survey at the national level confirm that these two sites were the site of infection, with 44 and 38 people infected having contact with these two sites. We will see later this national screening. As you see, the two first cases were identified on 2013. The river was closed the year after, and surprisingly, the schistosome resumed here after the river closed. New cases occurred in 2016 and 17. Important to notice that we are sure that this patient only went to Corsica this year. In 2015, it is a new infection. Now, the last cases is more complex, because in 2018, the patient went to the Corsica River in 2018, but also before. But now, we lose totally the when, because there is high fidelity of the Corsica, of the river, the people go every year to the same place, whether locals or tourists, they go to always, all the time on this river. And now we have difficulty to know when the people were infected. You certainly know that there is not only these cases. After the first emergence, there is a big screening at the national level. 40,000 people has been tested in France, and 106 cases has been clearly identified to Corsica infection. And using modeling approach, more than 300 people are certainly infected in Corsica. Important to notice that these 4,000 people are not all exposed to the Cavo River. Imagine you have a big campaign, and in this campaign, the French government said, if you went to Corsica in 2013, go to the hospital and make a diagnostic. Some people went to Corsica, but not in the Cavo River, and some other people never went to Corsica. Just because they're afraid, you said there is a dangerous parasite in France, please, please, make me a test. Okay? Thus, we don't know the relation between exactly the number of people exposed and the number of positive people. Okay? After that, schistosomiasis becomes a notified disease in France, and if you recover this case, is thanks to this process, and when we have positive schisto in France, there is a declaration to the health authority, and we know if the patient is infected in Corsica or in Africa. Also important is the problem of diagnostic. In this paper, there is a clinic of all the cases, and the paper showed that 2/3 of the patients were asymptomatic. The median of the diagnostic occurred 7 months after the exposition, and only 1/3 excreted eggs of schistosome, which is the gold standard to say this is a schistosome infection. This problem of diagnostic has been intensively debated in the publication, and this can explain why the contamination continue every year. Okay, then we were interested in the genetic of the parasite. We have collected eggs from different patients, and you see there are classical shape of schistosoma hematobiome. This is a classical shape and some atypical shape. Surprisingly, we have obtained one patient with this kind of eggs. This eggs is typical for schistosoma bovis. Bovis is an animal parasite, it's parasite infected animal and not parasite infecting a human. After sequencing, we confirm that the parasite is an hybrid between schistosoma hematobiome and schistosoma bovis. Half of the eggs were pure hematobiome, the other part were hybrids, and only one egg was characterized as pure bovis. We performed whole genome sequencing of the parasite of the hybrid parasite, and we observed that it's not only a capture of mitochondria, but a fully enterograssed parasite with 23% of the genome coming from the parasite of animal and not the parasite of human. Thus true act. At the patient level, we have obtained only 12 patients on the 106 cases. Yes, I have to explain. In Perpignan, we have obtained the urine of locally infected patients. The urine comes directly from Porto Vecchio to Perpignan, and we have performed the parasitological screening on the urine. And the other cases were in France, in Paris, Lyon, Marseille. That's at the scale of the patient. 4 patients were producing hybrids, 4 other patients were producing pure, other pure and hybrids, and only 1 patient with the famous pure bovis egg. After that, we try to infer the origin of the parasite using the COX-1 gene of schistosoma hematobiome. We can see that this gene cluster with one group of parasite on the mainland Africa. This is not very discriminant because there is a lot of countries in this group. However, using the other gene coming from the bovis parasite, or the animal parasite, we can see that the haplotype from Corsica cluster with some other haplotype of parasite coming from Senegal. Thus, this suggests that the parasite in Corsica come from West Africa and certainly from Senegal. This has been confirmed by the haplotype network. We can see that the most common haplotype we have found in Corsica is the same as the most common haplotype currently found in the north of Senegal. Why is this origin? It can be explained by that Senegal is a former colony of France. The relationship between Senegal and France are very important. Senegal is the first destination for tourists in sub-Saharan country for France. And in the rivers, France is the first. Okay. For rats, here, we sacrifice the rat. We capture very few rats, only 34, yes. Some mice, some hedgehogs, some shrews. And after hepatic perfusion, we found 2 rats with traces of infection. Not infection. This we have collected 1 male worm, and on the mesenteric system we found some black pigment on the first rat, and also black pigment on the second rat. I don't know if everybody knows what could be this black pigment. The black pigment looks like the hemozoin pigment of the female present on the content of the gut of the female. And we also observe 7 granuloma on the liver of this rat. Okay, this is an illustration just to show you what is the granuloma. This is the liver of a mouse, not a rat. Okay, we did PCR on this on biopsy of mesenteric system, on the granuloma, on the worm, and we confirmed that it was really schistosome. Just to explain, these are the control, schistosoma hematobiome Corsica from the lab, rat from the lab, negative, schistosoma hematobiome from Cameroon, schistosoma bovis from Spain. The profile is different than the hematobiome. These PCR correspond to, worms biopsy and biopsy of the rat number 36. This is the biopsy of the other rat. This is this biopsy, positive, and this is negative control. We have collected some biopsy of suspected negative rats in the field. After sequencing ETS and COX, we observed that it's exactly the same profile than the parasite introduced in 2013. Okay? I regret I have totally omitted to collect blood in all rats. It's a mistake. Because I imagine if I have collected blood, we can do PCR on the blood to know if all the rats were exposed or not. Too late. We have also performed, yes, in Perpignan we maintain 14 different life cycles of schistosomes. Plus you can perform experiment, a lot of experiments. We try to do experimental infection of rodents, of rats. Important also to notice that we infect Ratus norvegicus, and in the field we have captured only Ratus ratus. There is no lab strain of Ratus ratus. There is only lab strain of Ratus norvegicus. One colony exists in the veterinary school of Lyon. One colony of ratus. We expose the rats to different doses of Cercaria, and as you can see, the efficiency is not very good, similar than we observe in the field. Very few infections, but in this rat you have one pair plus and two male and some granuloma. Okay, thus the paper has just been accepted in close negative disease. At the conclusion we say that certainly that the rat is not implicated in the transmission, but is certainly relative to the role of the human host. One question now is, can you imagine other mammals we have not looked for in Corsica? The first one is mouflon. You know mouflon? Mouflon is a wild sheep. There is a colony of mouflon in the Saint-Martin Valley, but maybe it's unlikely to find this wild animal in the same place than tourists in summer. Maybe not convergence of contact with the water when the parasite is active during the summer, but we don't know. We did not test. I think it's difficult to capture mouflon and to test. The other is very strange idea, hedgehogs. Why hedgehogs? You have captured hedgehogs in Senegal. I explain why. This is very old publication from Brunt. I'm sure you don't know this publication because the publication is in French. Brunt works in Corsica on Schistosomiasis bovis. And I don't know why. Brunt catch hedgehogs and infect the hedgehogs. Why? Poor hedgehogs. And the hedgehogs was full of parasites. This is very strange. But I'm not a specialist of hedgehogs, but I'm not sure that there is a lot of water contact between the hedgehogs and the river. But it seems that hedgehogs can be permissive. Maybe you can see this is whole. You see there are worms on the mesenteric system here. The little intestine. Hedgehogs dead 37 days after the exposition. There are very few mammals in Corsica, like in other Iceland. The biodiversity is poor. I think there is no other possibility than these two mammals. Then, the second hypothesis is the resistance of the snail during the winter. Okay. First, to do an ecologistically realistic experiment, we put logger in the river to record the temperature in the river during 1 year. You can see that it's like a swimming pool. This is the temperature during the summer season, 25 to 30 degrees. You understand why so many people go to the Corsica Iceland. And in the winter, you can see that in average we have 8 degrees with a minimum of 5 degrees. And then in the lab, we have, you understand that we cannot test in the field because we never found infected snail. We test this in the lab. We expose the snail to the parasite. We wait for positive snail. We kept only positive snail, and we start to decrease the temperature of the tank 1 degree every day, and we maintain the mollusk during 14. It's continue. Okay. We maintain the mollusk during 14 weeks at 4, 8, 16, and 24 degrees. Then we increase the temperature. We wait for eventual Cercaria emission, and then we expose hamster, and we sacrifice the animal. Okay? This is just for the publicity. In this paper, we say it would be interesting to test the resistance of the mollusk during the winter. Thus, this is the result for healthy snails, healthy mollusks, from Corsica, Spain, or Cameroon. You can see that the mollusk from Europe can resist to 16 or 24 degrees without any problem. 4 degrees seems too low. Interestingly, you can see that the mollusks from Africa cannot resist at 8 degrees. There is some local adaptation. This is a nice result, I think. But if you notice, the capability of the mollusk to resist is higher than the temperature in the field, because 16 degrees is very low for Cameroon. And the mollusk resists to 16 degrees. It's the same in Europe. You see that the mollusk can resist to 8, maybe to 6, and 6 degrees is very low for Europe. Thus the plasticity of the mollusk is much higher than the temperature the mollusk experience in the field. And the funny result is the infected snail. This is the strain. The first is a strain of the. We did not test all the combination because it is very difficult to obtain positive snail with schistosomiasis hematobium. The objective was just to test a pure strain of schistosomiasis hematobium on the European mollusk and an hybrid strain of schistosomiasis hematobium on the European mollusk. 4 degrees, the infected mollusk die, similarly than not infected. The two at 8 or 16 degrees, the mollusk resist. At 24, the mollusk die. This is the effect of the parasite. Thus, this signifies that the parasite stop developing inside the snail, and the snail is still alive because the parasites stop hitting the snail. We submitted this result to publication, and one reviewer said this is similar than the estivation in Africa. The wintering is similar than estivation in Africa, certainly. Thus, you can see that, yes, the mollusk can resist over a winter season, and then we have tested, certainly not 2 winter seasons, because it's too much for the life expectancy of a snail. And then we have collected cercaria coming from, all the surviving mollusks emitted cercaria. All these mollusks emitted cercaria, and all these mollusks emitted cercaria. 1 month after increasing temperature. 1 month is the delay between the primary sporocyst and the secondary sporocyst. I think the parasite will start to zero the development inside the mollusk and emit cercaria. We took the cercaria, we have exposed them there, and we have obtained the same infectivity than the lab strain maintained at 24 degrees. No difference in cercaria infectivity. Okay. That's the. Okay. You can imagine that the mollusks survive 1 year during the winter, but not 2. Because it's impossible that mollusks infected in 2013 resist to 2015 or later. Sure that the best hypothesis is a human reservoir. Sorry, this is in French. This is the advice of High Council of Public Health, and this is very recent advice. And in this advice, there is reservoir host. We have to do information, formation, communication, training, etc. All together to the elimination of bilharziasis. Okay, there are some booklets in French, in Italian, in English for sensibilization, and so it's in French. There is now a new campaign of diagnostic in whole the Corsica Iceland to look for human reservoir. Okay. Just what we do now in the lab to study these hybrids. We are currently performing crossing between pure, it's difficult to say pure, I think, when we speak about schistosome, expected pure schistosomiasis hematobium, and expected pure Schistosoma bovis. Okay? Thus, the idea is to know the fitness of these hybrids compared to parents, because in the field we cannot. We do this in the lab. We have crossed the two, this is the Corsican strain with 2/3 from or more from schistosomiatobium, and this is the bovis part. We make crosses. We have made crosses, mirror crosses with the male hematobium, female bovis, male hematobium. We have also performed second generation and several lines back crossing with either schistosoma hematobium or schistosoma bovis. And then we analyze several life history traits like mollusk parasite compatibility, life history trait of the host and the parasite, mate choice experiment, comparative transcriptomy, comparative genomics. I will show you some result. Yes, schistosoma bovis have a particularity because it possesses a different snail host, Planomerus metigensis. Planomerus metigensis is the intermediate host of schistosoma bovis in Spain, in Portugal, in the north of Africa. You can see that the pure hematobium strain is unable to infect the strain. It is expected. It's funny to notice that the pure strain cannot infect the Corsican strain. Okay. This is the pure bovis strain. And when we cross, we can see that the two hybrids can infect the two parental mollusk host, and now the hybrid is able to infect the Corsican strain maybe that it is because the parasite was an hybrid that we have the parasite in Corsica. This is on the compatibility. Just to show you rapidly some result on circular infectivity, female prolificity, egg size. This is the life history trait of the parents. We have similar results than the cross between schistosoma hematobium and schistosoma intercalatum. You can see that the infectivity of the cross is twice compared to the parents. The prolificity of the female is twice compared to the parents. Thus higher infectivity, higher prolificity of the hybrids compared to the parents. The more strange is the size of the eggs. You have obtained very big eggs, and when you sum all these life history traits from, this is only from some lines, I presume a lot of results. The hamster died at, I think, 45 days after infection. This signifies that the period of development is divided by 2, and all the hamsters were dead. Thus the parasite is very, very virulent. We have performed mate choice experiment. We have proposed to a male schistosoma hematobium, female schistosoma bovis, or female schistosoma hematobium. Of course, we made all the combination, and whatever the combination, there is no choice. Total random mating. This is strange for schisto because schistosoma are known to choose the sexual partner according to the species. And finally, using this experiment, we have, just to show you some different results, we have performed RNA sequencing on the worms, mated with the good female or not the good female, or the good male and not the good male, the male of the same species. You can see that the first axis split between male, transcriptomic differences, and female. Okay? The second axis split between hematobium and bovis. Okay? But there is no difference when, for instance, you take the transcriptome, the whole transcriptome of schistosoma hematobium mated with female schistosoma hematobium. The transcriptome is exactly the same when you have schistosoma hematobium mated with female schistosoma bovis. Okay? And you can see that all the points are the same. There is no influence of the sexual partner on the transcriptome of the individual. Okay? Just I will conclude on what lesson we can have on this outbreak. This is the convergence between three different aspects. Climate change, certainly, because the river in Corsica have increased from 1 degree in the last 30 years. Thus 1 degree for green snail shows that this increase the population of the snails. Migration, of course. I explained why we have obtained this outbreak, certainly due to migration. Whatever legal or illegal is not the problem. You increase the migration and thus you increase the transfer of the parasite. And this is especially maybe to Corsica. The tourism have increased considerably the effect of this emergence. And you saw that more than 100 people infected. Just then maybe to be modest face of this parasite, because in one side we talk about eradication, elimination of schistosomiasis and the publication. And the other side, in France, we have emergence of schistosomiasis. You know, in France we are not a developing country. We have a lot of money for public health. The contamination in 2013, the cost was evaluated to 500,000 euro. More than 2 million euro was spent after the emergence of 2013 in Corsica. Okay? Thus, I think there is a million years of coevolution between the human and the parasite, and even in developing country, this parasite can resist, can persist, and we have a lot of difficulties with to eradicate the parasite. Okay, just I want to thank you. If you want, we can take picture, and you will have all the publication on the story of schistosome, not only my publication, of course. There's about 20 publications now on this outbreak, on all the aspects, and I think it's one. You can try. Thank you.
Thank you very much. So, questions?
I think that's really interesting about the estivation thing you've been looking at with the temperature changes. But I was wondering whether, so like often when like the work in like Africa, we're looking at estivating snails that are actually surviving hotter temperatures in the dry season, and the theory that some of them might be burrowing and actually withstanding hotter rather than cooler climates. So I wonder whether like there's a way of adapting the experiments you're doing for this to go the other way and see the behaviour changes and the persistence of the parasite in the snails in drier climate, in drier periods, and things like that.
I think it's possible to do the experiment in dry condition, to put a snail in the mud and to maintain during several weeks or months. It's just correlative idea. I don't want to mean that you will have the same process in Africa. But the result important is that the parasite stop the development, but the parasite is still alive. Thus, maybe during an estivation process, you have the same effect. The parasite stop and the development stop. The big difference is the temperature. The enzymatic reaction will stop at cold temperature and will not at higher temperature during the estivation process. I don't know. But we can only do this by experiment. Because maybe in the field...
Yeah, it's difficult.
Yeah, it's difficult because the prevalence is too low to test.
Yeah.
Are the schisto snails present in other places around Europe, or just as we know on Corsica?
Outside than Corsica in Europe, we did the malacological survey in Corsica, and now the snail is restricted to the zone from Porto Vecchio to the south of Corsica. The snail disappeared from all the other coast of Corsica. Certainly because there is another competitive mollusk, Potamotipirus jenkinsi, that replaced the Venus snail.
There has been outbreaks in Portugal and Spain before, wasn't there?
There are Venus snail in Spain, near Perpignan, in Italy. We have some specimen in Perpignan, living specimen. We have a breed of snail from Sardinia, yeah. Thus Spain, Sardinia, all the military in Iceland.
Have you been looking at other European countries like Italy, Spain, Portugal, for example, that have similar ecological or environmental conditions than the Cavern River in Corsica? Just to see if there is any reported case there, because I guess, for example, in the south of Italy, you also had strong immigration, and just contacted some hospitals, some public health agencies there to see if they have any reported case. And also in particular, I'm thinking cases where you have bovies circulating, so bovies in Spain, for example, bovies in Portugal, where you could maybe facilitate some...
I know that there is a site in Almeria in the south of Spain, with the conditions are similar than in the Cabo River, and there are a lot of migrants coming in Almeria and diagnosed in the hospital in Almeria. But is it what you want to mean, that there is other place in Europe?
Yeah, I mean other place where there's been same sort of outbreak as Corsica with local infections. So if you had been in touch with hospitals or places or towns like this close to...
No, this is a problem. In Europe, there is total disconnection between us, ecologists, and physicians, and at least in France. You see that we have obtained only 12 patients on 106. Why? There is no clear connection between our work and the work of the physicians. It's easier to work in collaboration in Africa on schistosomiasis between physician and ecologist than in Europe. Sure. Thus, the connection is not so easy to do between the physician. I don't know, sorry, but in Spain I'm sure it's like in France, in Italy it's like in France. There is a clear difference between the physicians, the work of the physicians on infectious disease, and the work of the ecologist on infectious disease. Thus, I know this hospital in Almeria, there is, near the hospital there is a big lake, and we have received some samples of migrants. Yes, the migrants are infected by
yeah,
schisto,
but it was
but
not local, it was not infection in Spain, it was...
there are bullinus on the lake near the hospital. Is the reason why we have been contacted, because there are bullinus on the lake, there is a hospital, a lot of migrants.
Did you try some of the same?
No, but for what? No. We stopped to... yes, every year. This is a part of the epidemiological control funded by the Regional Agency of Health in France. Corsica pay my lab, not a lot, to test every summer more than 4,000 to 5,000 snails by PCR. Of course, we crash several snails.
For elimination program in action, killing all the snails. So did you test these 12 the boys coming over as dishwashers, and were they infected?
No, it's prohibited.
But really, because
Yeah,
you do
yeah.
some really nice phylogenetics and
No,
just see them
it's
as
prohibited.
point
Yes.
sex.
Yes. I remember when I explained our result to the French authorities in Paris, I explained that we found the origin of the parasite, Senegal,
Yeah.
with the help of Bonnie, and I encountered these guys coming from Senegal, and no, you can't say that. Why?
But even if you didn't say it, did you manage to get any samples?
No,
from them?
it's impossible, because it's not allowed to target a person and say, come, and because you are infected. You can understand why. And I remember during this meeting, one physician said, yes, but if these people works on the restaurant, there is a contract. If there is a contract, they can go to consultation on the physician in terms of working health. I can médecine du travail,
Yeah, occupational health.
occupational health, and it was a solution. And one other physician said, no, it's not allowed because bilharziasis is not a disease linked to the profession. You cannot contract bilharziasis washing
Not
the
foodborne,
dishes.
yeah.
Thus, you cannot ask this guy to go to the consultation to do the test.
Unless they wash the dishes in the river.
no, in the restaurant.
Yeah.
Except if they wash the dishes.
Yeah.
Did you advise them to take Vesicontrol? These.
You know that when I encountered the young, I remember it was during the end of the season of the restaurant, and I met these Senegalese boys, and there are all the people working on the restaurant all together, eating a pig, grilled pig, in Corsica. And these Senegalese don't want to speak with me because they know that I know what is bilharziasis. And until a few minutes, I discussed with them and with all the group, and said, oh, yes, and at this moment, I understand that this guy comes from Senegal, from the north of Senegal.
Nice.
Thus, I said yes, it could be interesting
If
to...
you can get their ID, we can pick them up in Senegal.
When I phoned to Professor Berry, I explained to Antoine Berry that, oh, Antoine, maybe I found the origin of the infection. I met some Senegalese in a restaurant during a lunch during a party. And he said, oh no, it would be simplest to send praziquantel to the airport in Dakar than to treat in France. I did not understand. At the moment, I did not understand. Why do you say that? And after, I understood that it's more simple to send praziquantel to Senegal and give praziquantel like this than to have a consultation with a physician in France.
We know what happens in when it gets sent to Dakar. But anyway, more questions?
So I was wondering if you've obviously done a lot of the genetics work on the parasite, but what about the snail? How closely related is the truncatus to like other?
Genetic on snail, you say?
Yeah. How closely related is it to other European truncatus, like things like Spain, Portugal, but also those in West Africa?
We do not done any experience, any test on genetic on the snails.
Okay.
The problem with Bullinus is selfing.
Yeah.
Yes. That's genetic is complex. Sure that we will have fully distinct strain between Corsica, Cameroon, Spain, and okay. Genetic distance will be 1 between each of the population and
And your hedgehog, your Aeson, you're going to have to use Stefano's mini floatat because the hedgehog is now an endangered animal.
yeah.
So you're going to have to do non-invasive further.
Yeah, sure.
Yeah, you can't go around killing hedgehogs.
Yeah, but I'm not sure that hedgehogs, hedgehogs, impossible to sacrifice hedgehogs. Sure, using the
got to do that.
method. Yeah. But it's just an idea because I made the link between the hedgehogs we have captured and this publication.
Yeah, you just don't want them to be suddenly be a lab species or something.
Yeah. No, we will not kill hedgehogs. It's so pretty.
Bonnie?
Your lab strains, particularly the hematoma and your Corsica strain, are they happy in the rodents?
No.
They're still not?
No.
Okay.
We start to lose the strain, I think.
Okay.
I think you know that the material strain start to decrease, and maybe we will maintain the life cycle 2 or 3 more cycle, but no more. It's not important. We will go to Senegal and it's not Corsican strain, it's Senegalese strain.
Did the snails shed well after infection? How well infected are they? Do you get a lot of Sakari per snail from the Corsican strain?
It's not a good. I don't understand why this parasite emerging in Corsica, because it's not very efficient.
Yeah.
Really. But it's totally different. You cannot. Yes, I do experiment in my lab, but sometimes you cannot compare the infection in the lab. And for instance, when you cross Hematobioma bovis and you have positive infection on Planorbarius, this is a true result. Okay. When you expose the snail from urine in the field and after 1 cycle in the lab, it's totally different. Just one example, when you go to the field, we went to Côte d'Ivoire, Senegal, Cameroon, and Benin. And every time we go for a different project. And every time we go with snails to expose the snail with the true parasite, with the urine of the children. And we come with, with the 3 strains from Europe, Italia, Corsica, Spain, and 1 African strain. And we test the infectivity of the parasite. We have always more than 50% with only 1 miracidum. When we come back to the lab, we make 1 cycle, and after we have 5%. Yes. There's one parasite arrived from Senegal. The mollusk was easily infected. Now we have a lot of difficulty to maintain the life cycle. You cannot imagine that this parasite is able to maintain in the field in Corsica, not our lab strain.
As we know, hematoniums on its own is really difficult.
Yeah.
Hematoniums are pretty much overtaking mancinite.
Yeah.
Any more questions? No? So just say thank you very much indeed. Super.